Welcome back to our course. So in the last session, we completed our basic code. So now we are able to purchase 800 stickers, and we can simulate this process 100 or 1,000 times and also calculate summary statistics. And now in this session, it's now time to automate our code by writing a function. So what advantages do we have by writing a function? Well, let's assume we are after our Football World Cup sticker album, we want to buy another album, let's say Disney Frozen or whatever. And this has only a capacity of 450 stickers. And we only have a budget for 600 stickers. So instead of copying and repeating all of our code, which we created above, it's easier to have just a function and change the parameters like capacity or stickers you want to buy, and then getting our result with maybe one line of code by just calling a function. So this means less work for us and also much better readability for others because we are saving many lines of code. And whenever we have repeating lines of code, it might be a good idea to transform this into a function. And also when we are going to more advanced analysis or want to answer more advanced questions where we have to change or vary parameters and run our code many times, it might be more efficient to create a function and just call the function and vary the parameters. All right, so let's define a function called sticker album, and we have several parameters like album capacity, purchase stickers, simulations, and also the seed. We might also change the seed later on. And we are now defining so-called default values, or default parameters. So whenever these parameters are not specified when the function is called, the function automatically takes these default values. So for example, for album capacity, we set the default parameter to 600, for purchase stickers to 800, and so on. So this is called the function header, where we define the function. And in the end, the function should return something like a summary statistic like mean or median. But for the time being, we are just returning a nonsense string. This result is a result of sticker album to just check if our function in general works. So let's execute. So now we have defined the function, and now we can call the function with the default parameters. So whenever we don't define any parameter, the function takes the default parameters. And now we get this is the result of sticker album. So in general, our function should work here. All right, so now let's take care of the function body. And there's actually not too much to do. We have just to copy our code from above, our running code. It's this here. And we only have to make some minor adjustments. So instead of the parameters itself, we have to replace them by the parameter names. For example, here seed, because we are defining and calling the seed in the function. For MN range sims, and also we replaced here now the album capacity. Before it was 600, now we have album capacity. And that's it actually. And in the end, the function should return the mean of our simulations. And there we are calculating the mean. And in the end, we are returning the mean. So that's actually our function. And so let's run the function with default parameters. And we get 442.44. So that is actually the same mean that we get before. I can see it here. So our function in general should work. So now by having the function, we can answer more advanced questions. So typically, provider of sticker albums allow to directly order a particular amount of stickers, like say 50, and this makes it much easier to complete the album. So let's assume we can order the last 50 stickers, and that means we only need 550 unique stickers in our random process. And the question comes up, how many stickers do we need to buy to have a mean or an expected value of 550 unique stickers? And we can variate here in our function the parameter purchase stickers, and let's set it to 1485 and increase it by 1 until we reach the result, our desired result of 550 stickers. So as we have, I think we have 1000 simulations. Yeah, could take a bit. So now we have 549, so we are very close to 550, so we can further increase the number of purchase stickers. $549.7. We are very close. So in the end, we need 1491 stickers. And we can also automate this process by introducing a for loop. So for e in range 1048 and let's say 1495. So please print me the result of sticker album, and purchase stickers equals to I. Let's see what we get. There you can see it takes a while. So 1000 simulations are quite demanding for our machine already. And later in NumPy, it will be much faster, definitely. What you can also see here in the results that there's some variability. So our mean is not only going up as expected, like here, it's also going down in this step. And that's not a mistake. It's simply the curse of randomness in statistics, and that's so-called random noise. And to reduce this random noise, we need to further increase the number of simulations. So in statistics, 10,000 simulations is a widely used number of simulations that result in an acceptable variability of results. So now we are still there. We are finished now here. And we can also try now to make 10,000 simulations. All right, so welcome back. So now it took a while. 10,000 simulations are quite demanding for the machine, but we have a mean of 550.07, so this is very, very close actually. And to understand the impact of randomness and the severeness of the so-called random noise, we can also variate the seed and see how reliable our summary statistics are. So we can here say, okay, we are changing the seed 10 times, and we are simulating here 10 times. We have 1000 simulations, purchase stickers 1491, and let's see how different our results are. All right, so welcome back. So it took a few minutes, and as you can see, there's not too much variability, and the random noise is quite low here. So we have results between 549.7 and 550 something. So that should be a very reliable actually. But apparently the Python standard library somehow reached now its limits with regard to speed and performance, because here the simulations took quite a long time. And what we can do is we can measure the time 1000 simulations take with the so-called magic function time. And now we can see here it took us 3 seconds, and we will keep that in mind and compare it later to our NumPy code. So we finished this session and I hope you enjoyed it, and yeah, we will see us in the next session. Bye.